Thanks everyone for taking time to attend today's webinar on accelerating the MBSE process and knowledge management using MapleMBSE. So before I start with the webinar, I'll give you a quick introduction of who we are as a company. MapleSoft, we are into mathematics, modeling, and simulation. Our core product, Maple, it is a math software to solve advanced analysis and complex math problem. We also have a tool more focused on the engineers on the calculation management aspect called MapleFlow. And also on the simulation side, we have MapleSim for system level simulation. And the topic of today's webinar, system engineering tool MapleMBSE. It is a tool to provide an easy way for stakeholders to contribute to a system model. We will see in detail about MapleMBSE. So before that, for any product development, we start with the requirement and develop our model, like the architecture model and testing and prototype. So I've tried to capture it as simple as possible here. And I know that we all wish that the whole MBSE process is simple as that. But just for us to move from the requirement to the architecture model or the descriptive model, we face so much issues or complexity provided by the modeling language like SysML. It's very complex to understand and work with it, and also a resistance to change. So if you're implementing MBSE process and you want stakeholders to buy in and start contributing to the model development, there is so much of resistance because of the new process, new modeling practice, and so on. And as a result of this, what generally happens is that we, in order to involve these stakeholders who are not familiar with the modeling language, we provide information in terms of emails or certain documents or spreadsheets on which they perform their work, and then give it back to the system engineer who needs to then update the system model and so on. This leads to many errors because they are not working with the latest information, and this leads to project delays because of the error or working with the outdated information and so on. So what MapleMBSE provides is MapleMBSE provides a simplified approach to system modeling. So our main goal here is to keep it simple for the stakeholders to contribute to the system model and also to the MBSE process. And another major problem that we also address is to visualize large data. So using MapleMBSE, we can break it down into tables and matrices to provide a better view for the stakeholders to understand and contribute to a system model. And in addition to that, you, as a system engineer, you will also have the control over what part of the model you want to expose to certain user group or to some subsystem engineer, and you control what information goes into the model. You control what information also is you also control what information is being exposed to the user and so on. And in addition to the above mentioned advantage, you can also bring in the collaboration aspect, because you can bring in stakeholders who are not familiar with the modeling tool and the modeling language or the whole MBSE process to contribute to the system model. And an additional benefit that MapleMBSE also would give you is to do some quality check. So you can define your own queries. It's more on queries that has questions to your system model. So you could find requirements that do not have a satisfied relation, or you can find certain action that does not have any object flow or a control flow. You can define queries as granular or as simple as possible. And you can also even ask queries like, can you display the actions or activities which has more than 3 parameters or more than 4 outgoing flow and so on. So these are the kind of queries that you could perform on the model to get a result. So in terms of advantage for different user groups, so as a system engineer, you'd be able to see the MBSE process benefits, like you'd be able to accelerate it up to 4x speed, because you can now bring in stakeholders to easily contribute to the system model without the need to understand a SysML modeling language, what are the different symbols that SysML has, what's the syntax need. So they could start working as early as possible. And for the program director, because now they all work with a connected model, they reduce in errors, which leads to reduce in project risk or outgrowing cost of your MBSE process. And for the subject matter experts, so they are the main goal. So they are the users that we envision MapleMBSE would be useful to. So for them, they are using with a or contributing to the system model with a view that is familiar for them, or a view that is comfortable for them. So to keep it simple, in your MBSE ecosystem, you would have the system engineers who work with the modeling tool. They are familiar with the modeling language. They build the system model and so on. So they create this whole ecosystem, and they can define the model up to a certain level of granularity. So beyond that, they would need different subject matter experts or other stakeholders to contribute to the system model to make it much more descriptive, to make it all traceable, and so on. But the issue here is we need to bring in stakeholders who are not familiar with the modeling interface. So this is where MapleMBSE comes in as a solution. So with MapleMBSE, you can provide a control modeling interface. So by control modeling interface, what we mean is you control which part of the model you want to expose to the user. You control what information given by the user and how it is to be captured as SysML elements in the model. And at any given time, MapleMBSE maintains a bidirectional connection with the system model. So it is not a file export or an import. You are working with the system model in a synchronized manner as how a modeling tool would interact. So now your MBSE ecosystem also includes the subject matter experts who will contribute to the centralized source of truth, along with the system engineers or collaborate together with other subject matter experts. So the way MapleMBSE achieves this is using a tree-based model transformation. So what MapleMBSE has is it grabs this SML model or a system model. It performs a model transformation, and this model transformation is what is being projected onto Excel. So the MapleMBSE uses Excel just as a user interface to display the model information and to capture user edits. And we so today's webinar, we are going to see an example with teamwork cloud model. So we would be able to leverage the aspect of permissions that a user has or that is being provided by the teamwork cloud server. We also have access to branch and revision, so you could select the branch or the revision that you want to work with. We maintain a continuous synchronization. So anytime that a new model has been updated, you will get a notification. And you also have the mechanism to lock model elements similar to how the modeling tool works. But in MapleMBSE, this is done automatically. So this would prevent user from overriding existing elements or conflict between two users working with the same model. So with all these capabilities, we can bring the collaboration aspect where you could have multiple engineers who work through MapleMBSE and then contribute to the system model. At the same time, a system engineer could also work with the system model, review it or add new information to it and so on. So what is needed from the system engineer or from the stakeholder to work with the system model? So in your modeling tool, for today's example, we are going to see a system model that is in Teamwork Cloud Server. I'm going to use Cameo to access the model. We are going to see what the model is about, and then we are going to open the same model in MapleMBSE and see how we can contribute to the model. So from a system engineer, what is required is you have a MapleMBSE plugin installed in your Cameo. You just need to select the plugin template that you want to work with. So by a template, I mean, you would be able to generate views for the subject matter experts. So these views would be, one would be, for example, say you want to create an hierarchy of the system model, or you want to maintain certain traceability for the system model, or you want to define a behavioral aspect for the system model, and so on. So you select a template based on a use case that you want to work. You drag and drop the information from the model containment tree. So it is as simple as that. You just need to drag and drop information to say, I need to work on activities that is in this specific package, or I need to create or work on the structural element that comes from this package, or requirements, and so on. So you drag and drop the information, you export the configuration file, and you share this file with the stakeholder who needs to contribute to the system model. So the stakeholder would just launch MapleMBSE, so which is done automatically if you double click on the shared configuration file. You connect to the server with a credential, you access a model that is in the server. This is open in an Excel interface. The user can review or edit the model and save it back to the server. So once this is done, the user or the system engineer can view the information, review the information to check what new data has been added to the model, and so on. So we will see a live demo of this workflow. So here in Cameo, I have the model open. So we are going to work with a simple model of a fitness tracker. So I already have a list of blocks that's being captured as the component and the subcomponent relationship. You can see here, I have defined few requirements for the model in a containment structure. And we also have the structural aspect of the model here. In case if I need to define some test cases, a package for test cases and use cases, where I've identified 3 actors and also a single use case. So let's say my goal now for the end user or the subject matter expert is to contribute to the specific model. I want them to refine the requirements further. In addition to what we see here, I want them to refine or identify few requirements, then refine that requirement to use case, and also break down the existing component and subcomponent relationship or the blocks into further subsystems. So here, let me open the configuration file. On Cameo, once you have the MapleMBSE plugin, you will see a MapleMBSE tab. You just need to click on the tab, then go to configuration editor, and you'll see the templates. So like I mentioned to you, you will be having different templates. For example, if you want to define an hierarchy, if you want to see the interface of the system, a package, or if you want to just create a refined relationship, and so on. So for this case, I have a template called requirements template. So once you select the template, you'll have a description to see what the template is about. So this specific template is to decompose the requirements, and you can also, if needed, you can refine it to use cases, or define new test cases and use a verify relation to link the requirements with the test cases. And finally, you can also define a satisfy relation that will link the blocks that has already been identified or a new blocks that the user could add to the requirements. So here, you'll also see like a simple section called sample, which will give you a view of how the information would look on the Excel view. So here it's just a predefined table or image capture of how the table is going to look like. So you can see here it will be the requirement worksheet would be like a breakdown of requirement, a matrix for the derived relation, a table for the component and the subcomponent relationship. So here, if you hover over the text field, you will also notice that you will have a tooltip to say what type of information needs to be dragged here. So I need to drop a requirements package. So I'm going to drag and drop a requirements package. So So here, as of now, I can still do an export. You could see that when I dragged and dropped the requirements package, export was enabled. Say by mistake, if I drag and drop a different element, you'll get a warning saying that this field will only accept a package. So I drag and drop the requirements package. I could export. So what this as of now will do is it will only allow me to create or define new requirements. Let's say my goal again is to make sure that the user could include new use cases to the model. Let's say I don't want to have or define any test cases as of now. I want to define a satisfy relation. So you can see new text fields are open where again you'll have tooltip to see what kind of package could be dropped here. So I want to drop a use case package. So I'm going to drag and drop the use case package here. And for the structures package in this field here. So once all the relevant information is here, you can see now the export button is enabled. I can click on export and save this file. So I'm going to save this file as a requirements template and click OK. So now I have exported a view or a template view that will help me to define new requirements or view requirement that we already have in the model and so on. So here you will have, this is a file that we exported. So whenever we export, we will also have a MSE file. So this is a configuration file that I mentioned in few slides before. And this is a template file that will kind of act as a way to convey what information is being displayed to the user. So you just need to share these two files as a system engineer. You need to share these files with the subject matter expert to contribute to this model. So once they have the file and with the MapleMBSE installation, you just need to double click on this file. So this will automatically open Excel and it will then take me to a login screen. So the login credentials for the MapleMBSE session would be same as the Teamwork Cloud credential. And like I mentioned to you on the slide, based on the permissions that has been assigned by the Teamwork Cloud administrator, you will have access to certain projects. Only the projects that you have access to will be displayed, and you will be able to access different branch or revision as needed, and you can open that model information in Excel. Right. So here, when you launch the config file, you'll see a login screen like this, where you can provide your server address, the username, and the password. So once your credential is validated, you will be shown different projects that you could connect to. So in this case, since we create a configuration file or a template from the sample model, so you can see that we are connected to the sample model. I'll click on the sample model branch. We are working with the trunk, so I'll leave it empty. By default, it will connect to trunk. And you click OK. So now what MapleMBSE will do is it will access the model from the server, and it's going to get all the data and display it into Excel for us. So here for the demo, I'm showing the modeling tool and MapleMBSE side by side. But for a stakeholder, this is not necessary. So for a stakeholder, they could just work with MapleMBSE. They would not need a modeling tool to be installed locally. So here you can see I have opened the model in Excel. On the top, you can see the server that we are connected to, the model name, branch, and the revision details. So this is just an worksheet or to provide a description to the user on what each worksheet view is about. So each worksheet, you can consider it as a view into the system model. So it is just a description. So here, in addition to the description, we can add instructions on how user could interact with each worksheet and so on. So here, I'm able to see the list of requirements that's in the model in a tree format. So you can see that these are the requirements. And here, these are the three actors that we have from the model and the use case, their association, and so on. So for a user to interact or contribute to the system model, For example, let's say I want to now add new requirement here. So I want to add a new requirement, let's say to the display requirement. So I'm just going to use the same numbering for the mission requirement display. And let's number this as .6.3. And let's say for the tracker, I'm defining a requirement for the touchscreen. And the specification would be something like, let's say, the touchscreen shall be resistive touchscreen. Okay, so I have just included a new requirement here. And here, this is a matrix view. I do not have any derived requirement defined in the model. So that is why it's empty. You can see that I have only one level of top level or high level requirements, and I haven't defined any derived requirements. So that's why we do not see any derived requirements to be listed. So these are the list of requirements that comes in as a flat list from all the requirements at the higher level. So let's say I want to define a new derived requirement with an IDDR1 and call this a resistivity. Let's say screen resistivity. Okay. And specification, something like the screen should allow multi-input touch, like multi-touch input. Okay, so here I have defined a new derived requirement. I want to link it to our existing touchscreen requirement. So I could just include an X. This would say that the relation or the requirement screen resistivity is derived from the requirement touchscreen that we defined in the previous worksheet. So here we have three actors. Let's say I want to define a new use case to and then associate it to an actor. Let's say the use case is to check the tracker screen. So this includes a new use case, and I want to associate it to the actor user. So user is responsible, or the user will check the tracker screen. So that's what is being conveyed here. The list or the drop-down list that you see here comes from the list of actors that we have defined in the previous worksheet. Right? Let's also define use case. So we define the use case called check tracker system. Let's create a refined relation. So we would, or the user would check the tracker screen, and this, let's say, is being refined by the, or refined from the touchscreen requirement. So here, what we are trying to do with the derived requirement on the requirement use cases, we are just trying to create traceability between the elements that we have defined. Okay, so now in the blocks tree, here we are already seeing a list of components that comes from the model. So here for a comparison, I'll show that to you. So it lists all the components individually, and for any part properties that we have defined using the direct composition, you can see that the breakdown would also be shown here. So for example, with the activity physical uh, system, so it has few subcomponents here, then the third level subcomponents and so on. So let's continue with the same requirement or the use cases that we have defined. We want to include a new component called resistive touchscreen. This would be a subcomponent for one of the existing subsystems. So it already has few subsystems, the top level of activity tracker. It has certain subsystems. Now I want to define another level for one of the existing subsystems. So for screen, let's say I want to define a subsystem. Whenever a user enters something that already exists in the model, you would see this to be highlighted as a duplicate key. This is because screen is already defined in the model. So for screen, let me define a new block called resistive touchscreen. So here we have defined a new block. So once the input was accepted, you can see the error is automatically removed. The new component is being added. You were able to see an additional row because we already have the relation that goes from the activity tracker to the screen. So that's why we are able to see it. So I'll just update the typo. So you can see that once I updated the typo, it also instantly updates everything. So that's how MapleMBSE works. So each worksheet is uh, interconnected. So the changes that you make in one worksheet is reflected to the other worksheets too. Right. So finally, let's say we want to now also define a satisfy relation between the new component that we created and one of the derived requirement or the requirement that we define. So here you can see this lists all the components, like all the unique components that we have in the model, and also the requirements here. So to create a satisfy relation, so there is a satisfy relation that already exists between the screen and the requirement called smartphone. So here I am just displaying the requirement ID and the requirement name. But if needed, I've just hidden the specification. So if we need to see any clarification on what each requirement is about, we could just check the specification to see what uh, text has been added to each requirement. Right. So here, this is a new component resistive touchscreen we created. I want to create a satisfy relation, say to the requirement called touchscreen. So these are the two requirements that we included now and this component. So I would say the resistive touchscreen satisfies the requirement 1.6.3. Right. So before I save any of my changes to the server, I'll also update the logs here to show where I have acquired logs from MapleMBSE. So from MapleMBSE, the moment I update one of the model elements. So here, let's say if I added a new sub requirement to the display, so that's why I've locked this specific requirement. We updated the screen block and introduced a new subcomponent. We included a new use case, so you can see we acquire logs for part of the model that the user interacts with. So that's why if there are different users working with the same model, they would be able to acquire logs and not have any conflicts when they have connected or simultaneously working with the same model. So you can see that we are acquired log only for the elements that we interacted with, but for rest of it, there is no logs that is visible. So to save my changes to the server, so my changes are still not reflected because I have not committed to the server. You can see that when we open the model, we opened with the revision 22. So I'm going to now commit my changes. I'm going to a tab called MapleMBSE in Excel. You have different options that you could select from. So to save to the model, I'm going to click on the icon Save to Model. It's going to show me a commit to TeamWorkflow dialog. The user can enter a message, add a new requirement and subcomponent, and I click OK. So this is going to add my changes to a newer revision. So you can see that we have moved on to revision 23 from 22. So to see my changes, all I need to do here is update. So once my project update is done, we would be able to see the elements appear in our containment tree. So you can also see the logs have been released. So every time you close or you save your changes to the server, we will automatically release the logs. So I'll create a diagram for us to see the new elements and how they are being captured. So here we have the resistive touchscreen. We introduced a new use case that linked to user, and we also introduced a requirement called touchscreen. So here you can see now the derived requirement comes in automatically. So here these are the new model elements or the relations for traceability that we included from MapleMBSE. So we defined a new touchscreen requirement, which was a sub requirement for display. And we created a derived relation to a requirement called screen sensitivity. We refined the touchscreen to use case, which is associated by actor. And then we also define a new block or a subsystem which satisfies our identified requirement. So you can see that for a user or a stakeholder who is not familiar with the modeling tool, they don't need to understand any of the syntax of SysML. So you don't need to also, or the end user who's working with Excel, they don't need to worry about what type of relation they need to create. So here you could see that just based on the information that is being displayed here, the user will only create a derived relation in this worksheet. So here they could create only a refine and similarly satisfy relation here. So as a system engineer, you define what type of relation that we want to capture from the user and where these information has to reside. So nowhere in the Excel interface, we said that the requirements added should go to a package called requirement, or the use case should go to a use case package or derived requirement and so on. So all that is defined in the template based on where you drag and drop. So we drag and drop the requirements package. So that is why this touchscreen requirement is added to the requirements package. And then the use case package, a new use case would be captured in the use case package. New component or a block will be captured in the structure package because that's the package that we dragged and dropped for our use case. So you see that for an end user or for someone who is not familiar with the modeling language and the MBSE process, how easy it is to contribute to the system model. And similarly, we have defined here the traceability and the structural aspect of the system. We could use different templates to perform, say, for example, like safety analysis, to view the interface and so on. Right. And in terms of typical application that we involve in, you could define templates for interface control documents. So we already have a template in the dropdown that if you just drag and drop a package with the list of blocks, we could define an interface view. You could do simply a design review of the model information. We can perform variant management, safety analysis, a trade-off analysis, and so on. In addition to that, like any spreadsheet activities that you already perform, for example, the safety analysis or making like the cost budget or energy budget, we could do that with MapleMBSE. Any task that requires specialized knowledge, like functional decomposition or decomposing requirements, defining hierarchy and so on. Or if you have a large list or a legacy list of components that you want to integrate into your system model, we could define templates that would easily integrate information and also to show any trace. So we already saw an example of defining a traceability or a traceability that comes from the model. So these are the different views that you could easily bring about using the template and the configuration through MapleMBSE. So for the system engineer, all they need to do is use one of the templates, drag and drop the model information, export it, and the stakeholders now connect to the model and contribute as we saw in the demo. So as a takeaway or a summary of what we have seen, what MapleMBSE provides is it provides a way of breaking down the complexity of your MBSE process. It hides or masks the complexity of the modeling language and provides a view that is comfortable for different users to contribute to a system model, which in turn accelerates your MBSE process because you need minimum training. You don't need to train the end user to work with XML syntax. They already work with the tool that is familiar for them, like an Excel interface. So that's the advantage or the main goal for the subject matter expert. For system engineer, the advantage is you get the easy buy-in and you can define your own queries to do like a model consistency check and so on. And for a program director, it in turns overall adds to uh, low project risk because you are now able to get everyone to collaborate and work on a single source of truth, and which in turn uh, reduces the cost of the project and so on.